Hello, algebra students. Well, today we're looking at section 6.9, function operations, day 2. And yesterday we looked at function operations, specifically addition, subtraction, multiplication, and division. And we saw that you can add two functions, or multiply two functions, or so on, and get another function. So today we're looking at another operation. It's called composition of functions, and this operation yields another function as well. So this is it. You read this g of f, this little circle symbol here, we read that of. Okay, so this is g of f. And that is the composition of functions, and that is a new function that we just called g of f. So you read the whole thing then, g of f of x, right? And another way of writing it is like this, g of f of x. And you read it the same way, but either way that it's written. We can sort of see the reason that we read it that way. If we just look at this, looking from the inside out, we have here, of course, f of x, right? So, but if we look at this, f of x is the input to g, right? So f of x is this thing here, and that's evaluated and is the input to g. So it's g of what? G of f of x. Okay, so that's why you read it that way. And that's what's going on with it. Okay, the output from the function f becomes the input to the function g. So we're going to actually just evaluate that for a certain value of x today. We're not going to actually write down what that new function is. We could, but that's not what we're going to do. Just as to sort of contrast that with what we did yesterday, we'll take a quick look at yesterday's notes. Day 1. Zoom in on it here. So we see when we added the functions, we obtained a new function, and we actually wrote down, here it is, okay, the rule for that new function that we obtained, in this case by adding f and g. So that's a new function. But today we're not going to write the new function we obtain. We're just going to evaluate it for a particular value of x. Okay, so let's look at our examples. Oops, there we go. And the first one, we have f of x equals x minus 5, and then we have g of x equals x squared, and we want g of f of negative 3. And here's how we're going to do it. First, we're going to evaluate f of x, and then use that value that we got as the input for g. And that will give us g of f of x for that particular x. We're just going to evaluate it. So we could write this one this way. G of f of negative 3. That's our specific input that we're putting into f, right, is negative 3. So let's see what that is. Let's go ahead and evaluate f of negative 3. And we could put that actually right into as the input for g. So let's just do that. F of negative 3 is negative 3 minus 5. So how did we get that? Well, f of x is x minus 5, right? And what did we plug in for x? We plugged in negative 3. So this is it down here. That's f of negative 3, right? Again, because f of x is x minus 5, we plug in negative 3 for the x, and we get negative 3 minus 5. So that's the input for g. And so that's, we can go ahead and simplify that. That's negative 8. Okay, so let's evaluate what that is. Well, g of x is x squared. So we're going to plug in negative 8 for that x. So it's negative 8 squared. That's 64. So we have evaluated g of f of negative 3. Okay, let's look at another one. So we have h is defined, and now we're going to find h of 3. Okay, we're composing h with itself, you might say. H of 3. So we could write that this way. H of 3. So that's h of, okay, simplify or evaluate that. We plug in 3 into h, right? That's what this says to do, plug 3 into h. So when we do that, well, here's h, so we plug in 3 into that. Plug it in for t. There it is. So that's h of, we simplify that. 4 times 3 is 12, minus 1 is 11. And h of 11, I'll write that a little bit better. H of 11 is, well, plug 11 into h. Again, this is h. We plug 11 into that. We get 4 times 11, plugging it in for t, right? Minus 1. And now we can evaluate that. That's 44 minus 1, which is 43. Okay, let's move on to the next one. Whoops. That just shrinks it. C. We have two functions again this time, f of a and g of a. And we want to find f of g of negative 9. Okay, so that is, I think I'm going to write this one off to the side so I have a little bit more room. F of g of negative 9. So f of what? Well, f of this, and the this that I just underlined is g of negative 9. So we plug in the negative 9 into g. So here's g. Plugging negative 9 into that, we have 2 times negative 9 plus 4. And that's what we evaluate, and that becomes the input for f. So 2 times negative 9 is negative 18, plus 4 is negative 14. That's the input for F. And so F is just taking 6 times the variable. 6a, F of a is 6a. So F of negative 14 is 6 times negative 14. We're just plugging in negative 14 for a. And then, so we just calculate that, and that is negative 84. Okay, and now these, we could put equal signs for each of these. Okay, one more. This is example D. We have g of x and we have h of x, and we're asked to find g of h of 6. So we write it like this, g of h of 6. So we have to find h of 6, and that becomes the input for g, right? So as the input for g, we will write h of 6, and that is, h is x squared minus 1, so we just plug in 6 into that. Plug in for x, right? So that's 6 squared plus 1. Which is 37. Okay, so you see what's, kind of see the pattern here. H of 6 is 6 squared plus 1, right? Since h is x squared plus 1, I'm sorry, I should read that. H of x is x squared plus 1. H of 6 is 6 squared plus 1. That's what we have here, because h of 6 is the input for g. So you just evaluate 6 squared plus 1 is 37. That's our input for g. So g of 37 is, here's what g is. G of x is 4x plus 5. So g of 37 is 4 times 37 plus 5. Just plug in the 37 for the x. That's 148 plus 5. And that is 153. Okay, so that's composition of functions. Again, we just evaluated these for a given value for the variable. We plugged in the variable and evaluated.